Your agent works perfectly in the demo, then falls apart the moment a real user does something unexpected. It loops endlessly, forgets what it was doing, or makes the same tool call 5 times in a row. If you've shipped a LangChain agent to production, you already know this pain. And it's exactly why a wave of teams quietly moved to LangGraph. To understand the shift, you have to understand what a classic LangChain agent actually is under the hood. It's essentially a while loop wrapped around an LLM. The model looks at your prompt, decides which tool to call, you run that tool, feed the result back, and repeat until it decides it's done. That abstraction is elegant for a quick prototype, but it hides something dangerous. You have almost no control over the flow. The agent decides everything, and you're just along for the ride. That lack of control is where things break. Imagine a customer support agent that needs to look up an order, check a refund policy, and then escalate to a human if the amount is over $100. With a traditional agent, that escalation logic lives entirely inside the model's reasoning. So when the LLM has a bad day, it skips the check, refunds $2,000, and you find out from your finance team. You can stuff more instructions into the prompt, but you're patching a structural problem with persuasion, and persuasion doesn't scale. LangGraph reframes the whole thing. Instead of one opaque loop, you build your agent as a graph. Explicit nodes connected by explicit edges. Each node is a step. Call the model, run a tool, validate output, ask for human approval. The edges define exactly how control moves between those steps, including conditional branches. So that refund check becomes a real node with a real rule. If amount is over 100, route to the human approval node, no exceptions. The logic you care about lives in code you can read, test, and trust, not buried in a prompt. The second thing LangGraph gives you is genuine state. In a graph, you define a shared state object that flows through every node, and each node can read from it and write to it. That means your agent actually remembers the order ID it looked up 3 steps ago, without you cramming the entire history back into the context window every turn. And because that state is explicit, you get persistence almost for free. LangGraph can checkpoint it. If your process crashes mid-conversation, you resume exactly where you left off instead of starting over. That persistence unlocks the features production teams actually need. Human in the loop becomes trivial. The graph pauses at a node, waits for a human to approve or edit, and then continues. Long-running workflows that span minutes or even hours stop being a nightmare. You can build agents that wait for an external webhook, time travel back to a previous state to debug what went wrong, or run multiple sub-agents in parallel and merge their results. None of this is bolted on. It's the natural consequence of modeling your application as a stateful graph. Now, the honest caveat: LangGraph is more work up front. You're writing more structure, thinking about nodes and edges and state schemas instead of handing everything to an agent and hoping. For a weekend prototype or a simple one-shot tool call, that ceremony is overkill, and a basic chain is still the right answer. The migration pays off when reliability, auditability, and complex control flow start matching more than how fast you can stand up a demo. So the real lesson isn't that LangChain agents are bad. It's that let the model decide everything is a prototype strategy, not a production architecture. The teams that migrated didn't do it for hype. They did it because their agents kept failing in ways they couldn't predict or fix. If that sounds familiar, it might be your turn to think in graphs.